Okay, so solving quadratics is what we're going to talk about in this lesson. So we already talked about when we solving quadratics with the square root method, and we said that we can only use this method when we have our highest exponent to be x squared, and x squared is the only variable in the question. So here our standard is we're going to solve quadratic equations, and we're going to use all these different types of methods, and we're going to have complex solutions, and we're going to have some real solutions in these problems too. So what you're going to learn in this video is how to solve quadratics by the square root method, and why do we solve quadratics, and how to find the roots, x-intercept solutions, and zeros. Um, Key vocabulary, we talked about this before, so I'm going to briefly go over this. A quadratic is when the highest degree of an equation is 2. Solving a quadratic means to find the roots, solutions, solutions, zeros, or x-intercepts. All of those mean the same thing. That's what these words mean down here, and I'll come tell you what they mean in just a minute. You use the square root method to solve a quadratic when the, well, let's say like this. When there is only one variable and the highest degree is 2. Or you can call that an exponent as well. Okay? So here, x-intercepts, roots, solutions, a zero is all where the graph crosses the x-axis. All where the graph crosses the x-axis, or where y is 0. Let me give an example. You have something that looks like this, or, and with the quadratic, you're always going to have 2 roots. I'm going to draw a picture of that example I just did. So negative 2, 0, and then 2, 0. And your quadratic might look something like this. And I'm not saying that it will, but it may. So that's what you learned in 9th grade. That all of an x-intercept is where the where the graph crosses the x-axis, or where the y value is equal to 0. But we're going to upgrade you now. So now we're going to have some other types of roots that are going to give us some answers, and now we might have something with I in it. So with the quadratic, there are 2 types of roots. We're going to have real solutions. You can have real solutions, or you can have what we call complex solutions. And if we have complex solutions, that means that we have a complex number. And we already know the definition of a complex number. A complex number is a number that can't be graphed on a real number line, and is made up of a real number and an imaginary number. So if we have complex numbers in our solutions, which is going to give us a telltale with I, then the graph is actually not going to cross the x-axis at all, or it can't be graphed in the real number plane. So you might get something that looks like a parabola that looks like this. And we're not going to dig too far on graphing yet, but I want you to recognize the types of roots. And as we go through these problems, we're going to determine whether these are going to be, our answers to our questions are going to be real solutions or complex solutions. Okay, so let's jump on into this. So let's try this one together. It says solve the following quadratic. So I'm going to drop a line, and I'm going to use the line method. I'm going to drop the line through the equal sign, and the line method tells me the variables, which is right here, that x. The variable belongs on the left side, and these constants here, I got to get them to the right side, and I'm going to have to use some type of operation to get them to the right side of the equation. It may be adding, it may be subtracting, it might be multiplying, or it might be dividing, but I know I got to get them over here on the right side. So right here, first I need to figure out what method am I going to use to solve this quadratic with. Well, if we look, I have a squared here and a variable here. So I know some kind of way that I have an x squared in my problem, and I'm not going to end up with any other variables in this form, so I can go ahead and use what is called the square root method here, since it's in this form. So here I'm going to move this constant because that is adding, so I need to do the inverse operation, which is the additive inverse here. And I'm going to, this goes away, so we get equals 2 minus 9 is negative 7. Okay, now I'm stuck with, I need to get the x squared part by itself. So I need to get my x squared part by itself. So I have to, in order to get x squared by itself, I need to undo this multiplication sign that's right here. So divide by 2. So in the very beginning, I'm going to highlight that so you'll know what part we're trying to isolate. We're trying to isolate this part right here. And the only way to get it in isolation is I have to move stuff from around it. So it can be on the left side by itself. So this is multiplication. Anytime you see a number and a parentheses together, that's considered multiplication. So now I need to do the inverse operation of that, which is division. And I'm left with, on the left side, this, and then negative 7 divided by 2, I'm just going to leave it as a fraction. If you like it better as a decimal, that's perfectly fine, but I'm going to leave it as a fraction because as you move up in math, you're not going to turn those fractions into decimals. They're going to stay fractions, and you just have to simplify them. All right, the next thing is I'm almost to this x, but it has a problem. It's in parentheses, and there's a 2 outside here. So I got an issue. So I have to now undo this 2 so I can get to where this x is at. So the inverse operation of the square of something squared is to take its square root. So I'm going to take the square root of both sides. And because this is squared, when I take the square root, it goes away on this side, and we get x minus 6 equals, and because that's a square root, I should have 2 answers. So I have to say plus minus the square root of negative 7 over 2. Now, I am back to what? 9th grade math. So I just need to get the x by itself. I am almost there. I almost got this x alone. So here, I'm going to do the inverse operation again. I'm going to add 6 to both sides. And now I have x equals, bring the 6 down, 6 plus or minus the square root of negative 7 over 2. Now, this answer is still not in its simplest form. I can write it. I'm going to write it right here. I can write it like this. But we have some issues because we talked earlier last week that we couldn't have a negative number under the radical. So we're going to have to go to the side and do some side work for this radical part right here. So that's what I'm going to do. I'm going to go to the side and do some side work, and then I'm going to come back to my answer. So I have to do the square root of negative 7 over 2. Well, we learned that anytime we see the negative sign under the radical, we do negative 1 times whatever the number is. And what we do know is that negative 1 is the same thing as I times 7 over 2. So we look at this. The square root 7 is a prime number, so I can't do anything with that. And 2 is a prime number, so I can't do anything with that. Therefore, this radical is not going to break down any. At least this fraction is not going to break down any. So I'll leave it as it is. But if you notice here, I have a pair. And remember, the radical is considered a house. You come out of the house if you have a pair. So I can put I out here because it has a pair. But that 7 over 2 is stuck inside that radical. So I'm finished with my side work over here. Now I can go back to my problem. I'm finished with the side work. Now I can go back to my problem. So x equals 6 plus or minus I, the square root of 7 over 2. And we're finished. And let me make sure I write that square root over the whole fraction. We are done with that one. Now there's another way you can write this. You can leave it in its condensed form, or you can write it like this. 6 plus I, the square root of 7 over 2, and 6 minus I, the square root of 7 over 2. Or you may see it as you get in college. Y'all, I can't write that little squiggly thing, so, go ahead and laugh. I already know I can't write it. Plus I, the square root of 7 over 2, comma. In college, they may show it to you like this. So I want to make sure you're prepared, because no matter what career choice you take, you're going to see quadratics again, baby. It is not going nowhere. So I'm going to erase this side word right here. You will see quadratics again, and yeah, they're not going anywhere. It's in every level of basic math. Okay, so these are 3 ways that you will see that. Okay, so now I got my answer, so I'm going to go answer these questions up here. The roots, solutions, x-intercepts are zeros, is r. Well, I'm going to write the condensed form of the answer. X equals 6 plus or minus I, the square root of 7 over 2. And then this question over here says, where the roots cross the x-axis, and then write y. It's going to be no in this case, and that's because they are complex solutions. So what this means is that I right there tells me this is an imaginary number. This is the real part, this is the imaginary part. So that means this graph will not cross the x-axis. It's going to look something like this, or it's going to look something like this. But it's not going to cross the x-axis at all. And this is your x-axis. Okay? We're done with that problem. Let me see if I got another one in here for us to do together. Nope, babies. Okay, so your job is to try this one out for homework. Refer back to the example so that you will be okay. And I'll talk to you guys in class on Wednesday. Bye.